Hello, my name is Christine Boy, and I will give you a very brief overview of the Task 3 poster. So Task 3 of the proposal is focused on the exports from fine-grained zones to coarse-grained zones and how they are transported in the coarse-grained zones after exiting the fine-grained zones, and also what the impact is on groundwater quality from these exports. So in the top half of this poster, you'll find more details on the experimental approaches that we propose, and in the bottom half, you'll find more details on the analytical methods. So if we first zoom in on the first subtask, which will be a column experiment to characterize the exports from the fine-grained to the coarse-grained zones using natural sediments from Slate River and Riverton, and then embed them in coarse-grained ferrihydrite-coated sand to get mass balances, and also being able to really characterize what kinds of exports are filtered out by the sand and carried on in the aqueous phase. And this is really feeding a lot of samples and data into other subtasks and to our collaborators. And this is where we most heavily will be relying on the analytical methods that you will find below, and I'll get to that in a moment. The second subtask of Task 3 really then focuses on what parts of the exports from the fine-grained to the coarse-grained zones that drive the establishment of reducing conditions in the coarse-grained zone. And we'll have a combination of incubation experiments that also help provide samples for Task 2, and then column experiments designed based on data from the incubations and also from Task 3.1 to really get at what components that are the most important for driving this kind of behavior. And there will be data exported to Task 4 from this objective. And finally, an even more modeling guided approach will be the third subtask of Task 3, where sensitivity analysis from Task 4 will be used to design an experiment that aims at getting to the bottom of what controls the extent of the reducing conditions in the coarse-grained zone. So for example, flow rates, ionic strength, etc. And this will really be tailored to obtain quantitative information that is needed for the reactive transport modeling, to include colloidal transport and reactivity beyond conditions that we've found at the Riverton site. So this is really to make it more transferable to other systems as well. Now, very briefly on the analytical methods, and I encourage you to explore this on your own later. There are synchrotron-related X-ray methodology over here, spectroscopy and microscopy, novel mediated electrochemistry approaches here, and then combined microscopical approaches such as STXM and nanosims that can be used to really get at what kind of elements are associated and included in different phases, such as colloidal phases, and also that may explain how colloidal phases are interacting with sediment matrix. More colloidal characterization approaches are explained here, including TEM, SEM, and Mossbauer. And finally, getting to the transport of colloids and other phases, we'll need to use a suite of different types of tracers, and so that is explained very briefly here. And I know everything is very brief, so please explore the poster on your own at your leisure, and also please feel free to post questions using sticky notes on the mural, or come to the breakout session and post your questions then. Thank you very much.